I want to start by showing you guys something really amazing. Yeah, that's an egg. I brought it all the way from Mankato. I did drop it in the parking lot. Didn't break. It was pretty exciting. But you know what's the big deal about an egg? Well, for most people without fingers, it's impossible to hold an egg because you crush it. So it's really incredible that I'm holding this egg with my fingers. So 3D printing is really a double-edged sword in this case, where you can create incredible designs that are extremely elegant, but they're not necessarily the most efficient design for what you're doing. And that creates a lot of poor designs, and in the case of prosthetic hands, it results in poor prosthetics for people that are going to be using them. There's also kind of a lack of software out there, and it's rather complicated as well. If you look at the image on the right, I'm sure you can, because I've looked at that image a few times and I still can't really tell what's going on with it as far as the data that is being collected there. And that's really a problem for people that are testing hands because they can't see what the hand is doing, or maybe they just don't know how to do that.
So the product that we're talking about today is the 3D printed prosthetics hand. It's full mechanical hands, so it's not robotic hands. And it's become really trendy recently because it's a really perfect option for low-income people and also for children, because children, they need to change their hand anytime until they start growing with being adult. So this is, I mean, if you compare the cost of this hand, it's around $25. If you compare to a full functional hand, which is around $100,000. So our idea that the majority of the designer of this product is open source community. And as John mentioned, that these talented people, they have really good talent to design part, beautiful part, but what about the quality part? Our idea is to design a testing kit to evaluate and assessment the gripping force of this hand. So the designer have the accurate and the required information to improve and ensure their quality of the product they designed. If you know that the majority of this designer, they are around the world, they're not just the United States, they are from maybe Korea or Middle East. So not all of them have access to test their product with real people. So they need a really good tool to provide them with the gripping force mapping so they can know the performance of their hand. Unfortunately, the majority of the existing technology is designed for testing the gripping force for the human hand, not for robotic hands. So the kit will be like free and affordable because the open source community people, they're really talented and they think into both things by themselves. So it's good to provide them with low cost product. And this can provide them with a accurate assessment, and also the most important part, the testing kit should be easy built and easy used. So it should be like universal design testing kit. So it's, as I mentioned, it's come in two options. So the open source community and majority of them, they like to build things by themselves. So just like my friend John, maybe he's not willing to pay to this technology. That's why it's come for two options. The first option, provide the open source community with the full plans, software, and tutorial to build the testing kits by themselves. And the second option is the pre-made kit, which is around $600. Can provide, in addition to the first service, can provide them with better sensors and also with step-by-step building tutorial. The testing kit consists like a robotic hands that mimic the wrist movement of the human hand, but also consists of a group of sensors that give a feedback about the gripping force of the prosthetic hands.
So why is our team the best one to do this? Well, as he said, my name's John. I'm a master's student at the University of Minnesota, Mankato. I have 4 years in the 3D printing industry, doing 3D printing as well as 3D design.
I'm Araz Al-Dawoodi. I'm a Fulbright student, and I study in manufacturing engineering technology with background in ergonomic and experimental design.
In addition to Araz and I, we also have Dr. Kuldeep Agarwal, who is a researcher in 3D printing in the biomedical field and a faculty member at MSU.
So our vision is for this product should be like universal design. That's why we need the designer, the open source community can understand and use this testing kit regardless for their background. And also should be like to improve the sensor ability and also provide a service testing to the open source community as well.
So what does this actually mean in the end? Well, for the inventors, for the designers, it means easy access and affordable access to this test equipment. And for the end users, like Haley Dawson, who actually got to throw the first pitch at a baseball game with a 3D printed prosthetic like the one you're passing around, it means better prosthetics that are going to work, they're task specific, and they can really make the impossible possible.